Today we're going to be working on solving systems of equations by graphing. You guys should have 3-1. If you look at the front page, it says the following chart summarizes the possibilities for graphs of two linear equations in two variables. What I need you guys to do is highlight. I need you to highlight the graphs of equations, the slopes of a line, classification of systems, and number of solutions. You are going to use this table to answer a lot of these questions on this worksheet. You must know this table. When I give you your next quiz and test, this table is going to be on there. So you guys need to memorize this information. So let's look at the examples. The example says I want to graph the system of equations and describe it as consistent and independent, consistent and dependent, or inconsistent. So the reason we know those definitions is if you go back up to that table. So we're going to use that table for a majority of this worksheet. Now you have an example already on the paper for you that you guys can look at, but I want to work a few of the problems on the front page. So I'm going to work problems 1, 3, and 6. And before you come back on Monday, I want you to work problems 2, 4, and 5. We will work the back page in class on Monday. So let's look at it. Number 1. Problem number 1 says I've got 3x plus y equals -2 and 6x plus 2y equals 10. Before I can actually graph both of these equations, I have to solve for y. I know a lot of you had trouble with this on the quiz on Friday, so please take good notes and write this down. So let's look at 3x plus y equals -2. I need y to be by itself, so I need to move the 3x to the other side of the equation. So if it's a positive 3x, how am I going to move it to the other side? You should have said subtraction. Now the other thing I saw happen a lot is you got this far and a lot of you were combining the -2 and the -3 together. If I have a variable with a number, I cannot put it with just another constant. So since I'm writing the equation, I should have that y is equal to -2 minus 3x. So this is my first equation. So let's solve for the second equation. Here I have 6x plus 2y equals 10. Again, I need to get y by itself. So I'm going to subtract 6x from both sides. Those cancel, and I have 2y equals 10 minus 6x. Now here, y is still not by itself. So what do I need to do in order to get that 2 to go away? That's right, I always divide. That's my last step. So here in this equation, I should have that y is equal to 5 minus 3x. And that's my second equation. So now that I have solved for both equations, you have a graph on your paper, and let's look at how we're going to graph it. Now, if you don't have a calculator, you should still be able to graph it, and I want you to know how to graph it by hand. So let's look at the graph. So my two answers, I had y equals -2 minus 3x, and I have y equals 5 minus 3x. So let's graph the first equation. I'm going to graph this one in pink. So here I'm going to go to my y-intercept, which is -2. So I go down 2, I put a point. Now I'm going to use my slope in order to come up with another point. So I have -3 as my slope. Now remember, we said that was the same thing as saying -3 over 1. So I can go down 3 and to the right 1, or I can go up 3 and to the left 1. It's the same thing. So here is my first graph. Okay, so let's look at the next one. I'll graph this one in blue. Here I have y equals 5 minus 3x. So positive 5 is my y-intercept, and I'm going to use the slope again to determine another line. So I'm going to go down 3 and to the right 1. So here is my second line. So are these lines parallel or perpendicular? That's right, they are parallel. Are they the same line or different lines? They are different. It's not going to be the exact same line because my y-intercepts are different. So let's go back up to the table and let's see what's going to be my answer. So based on the table, we said our lines were parallel. So here is where it tells me that my lines are parallel. So let's look at the slope of the line. It means I have the same slope and different y-intercepts. That's correct. So my answer is actually inconsistent. So again, on these few problems, we're actually saying it's consistent and independent, consistent and dependent, or inconsistent. So problem number 1 would be inconsistent. So now let's look at problem number 3. I have 2x minus 3y equals 0, and I have 4x minus 6y equals 3. So let's solve both of those equations first. So let's solve 2x minus 3y equals 0 first. So again, in order to get my y by itself, I'm going to subtract 2x from both sides. I get negative 3y equals 0 minus 2x, and I'm going to divide everything by a negative 3. So here my equation ends up being y is equal to, I have 0 plus 2/3 x, and that 0 can just go away, so I can actually write it as just 2/3 x. They're both the same answer. Okay, so let's look at the next one. I'm going to subtract 4x from both sides, and I have negative 6y equals 3 minus 4x, and I divide everything by a negative 6. So here I have y is equal to a negative 1/2 plus 2/3 x. And here's my second equation. So again, let's use those equations and plot them on the graph. Okay, so let's graph the first equation. I'll graph the first one in blue. Now my y-intercept is 0, 0. So I'm going to put a plot on the origin. And my slope is 2/3. So I go up 2 units, to the right 3 units. Up 2 units, and to the right 3 units. So here is my first equation. And now let's plot the second one, and I'll do this one in pink. My y-intercept is a negative 1/2, so I'm going to estimate. It's right about there. And then I'm going to use the slope again. I'm going to go up 2 and to the right 3. Up 2 and to the right 3. So your lines should be very close together, but they are parallel. Okay, so again, my y-intercepts are different, but my slopes are the same. So what do we say was that answer? If you don't remember, go back up to the chart. If my lines are parallel, but I have different y-intercepts. That's right. You should have written inconsistent. So number 3 is also inconsistent. So let's look at our last example, problem number 6. I have 3x minus y equals 2 and x plus y equals 6. So let's solve 3x minus y equals 2 first. So here I'm going to subtract 3x from both sides. I end up with a negative y equals 2 minus 3x. Now remember, what number is in front of that negative even though it's not written? That's right, a negative 1. So I have to divide everything by a negative 1 because I cannot have a negative y as my answer. So I should end up with y is equal to negative 2 plus 3x. And let's look at the next equation. Here I'm going to subtract x from both sides, and I have y is equal to 6 minus x. Now what number is in front of the x even though it's not written? That's right, a negative 1. So let's use these two examples and let's graph them like we did the other two. Okay, let's graph my first equation. I have y equals negative 2x plus 3. So I'm going to go up to positive 3, which is my y-intercept. I'm going to go down 2 to the right 1, down 2 and to the right 1. So here is my first equation. And let's graph the second one. The second one I'll graph in purple. Okay, so my y-intercept is positive 6, so I'm going to go up to 6 and put a point. And then my slope is a negative x. So we said it was a negative 1. So here I'm actually going to go down 1 and to the right 1. Down 1 and to the right 1. So forth and so on. Now I know you can't tell based on this graph, but had I keep extending these lines out and my graph was a little bit bigger, what's going to happen right here? You should say that the lines were going to intersect. So based on our table on the front at the top, if my lines intersect, what is going to be my answer? I have different slopes. I also have different y-intercepts. So what is my answer? That's right. Here we have consistent and independent. Okay, so you were given 3 examples. Again, I want you guys to try and attempt 2, 4, and 5 before you come to class on Monday, and we'll go over those 3. And then on Monday in class, you're going to work the back page. So again, if you don't have a calculator, you should still be able to graph using the y-intercept and the slope. So please let me know if you have any questions, and good luck, and I will see you on Monday.